Merci, merci. Salut tout le monde. The timer has started, so I believe so should we. Welcome to this session about migrating your application, your Java application, to Java 11 or newer version. And unfortunately or fortunately, I have to say that I'm happy and sad by seeing so many people in this room. Meaning, and you know what I mean, right? So I started giving this talk back in 2018, and I really hope that it's going to take the momentum, and we'll be all happily migrating our stuff to newer Java versions. But your presence here proves that unfortunately is not the case. So I'm sorry that you have to be here, but I'm also happy that I can help you, I hope, with this. Okay, so briefly about me, je m'appelle Piotr Przybyl, je viens de Pologne, j'habite à Pologne, and I speak French just a tiny little bit, okay? So this is my Twitter and Telegram handle in case you have to send me some questions, some comments, some hate, whatever you please. I work as software gardener in a company, in a great company called Atomic Jar, so we are the company working on test containers. And I also work as a trainer from time to time, like training people on this stuff, for example, moving to new Java versions, new Java version features, and so on. And I also blog every now and then at my blog post personal page, softwaregarden.dev, because I believe in this software gardening movement or description. And if you're intrigued what that is, please follow to my blog post. It's described there. So yeah, this is me when I go on holiday, provided we can go on holiday, yeah. So even when I go on holiday, Java is somewhere behind me, it seems. So most of my professional life is Java oriented or Java based. I also do some Scala, I did some Groovy, I work in Go sometimes, and most of the time I work on Linux, right? So this is me, and I'd like to know who you are. So who's using Java 8? Okay, yeah. Is there anyone using Java 7 or 6 or something like? Okay. Have any of you tried already like Java 11 or something newer? Okay, still it's not bad. Oh, I like it. It's not bad. Okay, so we know each other. Right. Little warning, caveat auditores. Everyone can make a mistake. I can make a mistake, okay? Don't trust, verify on your own, right? That's the message, briefly. Erae humanum est, as we all know. So, a little agenda for today. I'm going to cover some crucial non-technical changes today, like the business license and so on. We'll be talking about removed and deprecated stuff, just briefly, and basically how to run your application on Java 11 or something newer, right? That's the point of this talk, right? What's not in this agenda is, like, for example, something I did yesterday talking about Java 16 or 17. I'm not going to cover all this new stuff, like, for example, var or tooling or new language features and so on. This is not going to happen. The purpose of this talk is you touch your source code just when you have to, right? And nothing beyond. So it's not about rewriting your application just to make it move and run on Java 11, JDK 11, right? So first, let's start with this difference: Oracle JDK versus OpenJDK. Who has heard of OpenJDK? Okay, that's great. That's great. That's great. I'd say majority of the people has heard of it. So in the back in time, it worked like this. You wanted to have Java, you went to Sun Microsystems page, you downloaded Java, right? Then there was Oracle, so people used to go to Oracle's database, web page, download Java, and install it and run it, right? But then OpenJDK happened, right? So when it comes to technical aspects, it's not like it's totally equal, but it's mostly equal, I would say. You will really need to get some like corner cases to sense or observe a difference between OpenJDK and Oracle JDK. So in these terms, they are equal. Both are maintained and released by Oracle Corporation, of course, and they are different. Meaning, OpenJDK is free. You don't have to pay for using it. And OpenJDK is like proprietary again, and it's like paid and so on and so on. So there's, of course, this new release schema, in case somebody didn't notice that. So new Java major release is released every 6 months. So somewhere like mid-March and mid-September, we see new Java version, right? And then we see like another minor release 1 month after, and 3 months after we see another minor release. So there are no other releases or something like this, right? And what's more important, it's the releases, unlike for example Java 9, aren't postponed by the feature. So if the feature doesn't make it or module doesn't make it, basically it's not shipped with this given Java version. It's that simple. It means you missed the train, you need to wait for another one, right? And now we most probably will see LTS releases every 4 releases, meaning every 2 years, right? So not like 3 years, but every 2 years. This is like one of the recent Oracle announcements that they changed this schema, this routine. And what it means, right, that the OpenJDK doesn't receive updates once the next version is released. And that was also initial promise for the so-called LTS releases, but as we have all seen, fortunately for us, we also see these minor releases of OpenJDK as well, not only for Oracle JDK, right? And you need to remember about this, that there are also other vendors and other JVMs. There are really many, and this is really growing. So let me show you this briefly. Let's say SDK. I'm using SDK Manager, SDK list, Java, C, and there's there used to be Adopt OpenJDK. Now it's Adoptium, right? So there's Corretto, there's this OpenJDK, there's Liberica, there's something from Microsoft. Yeah, because of the change in the license, even Java 17 can be here from OpenJDK, because it can be now downloaded without you clicking I agree. Basically, there is Temurine, meaning this Adoptium. There is Zulu from Azul. As you can see, even to install automatically, you have a choice, right? You can choose for your development machine which version of JDK, which vendor you're going to use. So it's not that there's only Oracle, and in for Oracle it's like Oracle JDK and OpenJDK. There's like the ecosystem of JVMs and JDKs is basically growing, right? And I've heard such questions even yesterday, right? People asking me like, okay, we'd like to migrate to this Java 16 or Java 17. You've shown that it has like really some cool features, right? Pattern matching, record, seed classes, but we can't do that because Java 11 is paid, right? Who has heard that Java 11 is paid? Okay. Oh yeah, some people had heard that. There was this thing, right? That some people were saying that Java 11 is paid, right? So people say different things. Some people say the Earth is flat, right? Some people say you need to be wearing a tinfoil hat because it's good for protection, right? And some people say Java 11 is paid, right? This is the same amount of rubbish, basically. Java itself is not paid. Therefore, you can repeat after me that Java 11 is not paid, right? To whoever you meet when they start doing this, or maybe you should also tell them to take off their tinfoil hats, basically, because Java 11 is not paid. Oracle JDK is paid. You have to pay per like CPU or CPU core or something like this, right? If you subscribe to a paid license or paid subscription from, for example, Azul or other vendor, you also have to pay, right? But this is like choosing the free product versus paid product. Like then you get like support, somebody answering your phones, emails, and stuff like that. Extended support for security and so on and so on. But Java itself is not paid. You can find this under this link, right? It was created by Java champions, so we can see like a proof and so on why Java itself as a technology is still free, right? Okay, so let's also stop for a minute or two and discuss this true meaning of LTS, right? Because there are many people saying, yeah, we should go stick with 8, for example, because it's LTS. Then we should jump to 11 because it's LTS. Then we should jump to 17 because it's LTS. Let's skip everything in between, right? So what is this LTS? It stands for long-term support, right? But as I believe Ron Pressler says, it's mainly business term. It has nothing to do with technical stuff. It means that vendor will be providing support for this version for longer than for any other version, right? But it's not like less functional, I don't know, less secure, or I don't know, has some hidden bugs because it's not tested or something like this. And it's even written quite nicely, like please don't read this whole world of text. It's written quite nicely in this email from Mr. Mark Reinhold himself. See whether the target release is an LTS or not is, in almost always, completely irrelevant. Because there were these people were saying before they released Java 17 that they should stop like doing the new stuff. Instead, they should focus on fixing stuff, right? Because Java 17 is an LTS, therefore it's somewhat more important. And as you can see, as you have seen, Oracle just changed their LTS policy, and there's no problem with other vendors providing, you know, their LTS even for every Java version, because it's a business term. Like, you came for them, you pay them money, so they do LTS for you. Why not, right? They will support it for longer, basically. So please remember that neither these LTS, non-LTS releases nor the preview features are, as some people call it, banana soft or monkey soft or something like this. It's not rubbish. It's as stable and as serious as any other version. LTS means business, money, such stuff, right? Not technical capabilities, so to say. Okay, who knows this slogan? Yeah, so I believe you started Java like at least a few years ago, right? So I started with Java 1.3, and we had this slogan, write once, run everywhere. Like write on Windows, it will run on Solaris, except, well, it would not, because it's depending on some like something else, right? So we instantly coined our own like answer, write once, debug everywhere. This was the actual reality back then, right? So when it comes to migrating to new Java versions, the general promise was like this, that normal Java SE applications should just work, right? And the question is, because there are two questions there. First, what does it mean normal? Who can say the application is normal? Maybe it's not normal, right? And then the other thing, should. It's not will, or we assure you it's going to work, or something. It should, right? But in case it doesn't, then it's outside this should. And of course we have the third thing, which maybe you haven't paid attention, is this standard edition. Meaning, if you have something outside the standard edition, meaning this enterprise or enterprise edition, then it's not even covered by this sentence, right? But we'll get to that. So in all other cases, the migration might not be a simple single step. Right, I've migrated some Java applications. Sometimes it was trivial, like it was, for example, moving from Java 5 to Java 6, for example. Sometimes it was painful, like moving from Java 6 to Java 7. So it really depends on the application and on the changes and so on, what you have in your application, right? So it's about this being normal or not. Okay, so how to convince the business? You're here because I guess someone didn't still have enough arguments to convince the business that it's really worth doing this, right? Provided it's possible, because sometimes it might not be possible because, for example, you're using a framework or library which relies on API which got removed after Java 8, right? Like some sun misconceived methods and something like this. Then I'm sorry, probably you're stuck with Java 8 until, for example, Panama kicks in and we have new safe ways of handling memory, like a native memory and stuff, right? So that's the thing. So how to convince the business? First thing, and this is actually what worked for me, the best thing is Java Flight Recorder and Java Mission Control. Have you ever used Java Flight Recorder? Few people, so it's not that popular. Meaning it was also available for previous Java versions, but since Oracle wanted to release Java every 6 months, they said, yeah, whatever, let's open source it. So they open sourced it, and now you have to use it. You can use it for free, right? You don't have to pay anyone or buy this Oracle JDK. I see you're taking notes. That's great, but if that's the case, you see the slides are online, so you can just grab the slides later. That's also possible. Okay. Right, so the Java Flight Recorder, which is really like a low overhead production profiler, meaning you can record, it works like this black box in airplane, which is actually orange, right? But we just usually say black box. So it's recorded, you know, the parameters of the flight, like the altitude, atmospheric pressure, what pilots say in the cockpit, right, and so on. And so is doing the Java Flight Recorder. It records the stuff, or it can even stream stuff, like from Java 14, I believe, right? And then you can it's recorded to, for example, a file. Then you can open this file in Java Mission Control, and then you can see how Java behaved during this flight. You mean JVM, like memory allocations, you know, GCs, threads, and so on, right? It's for free. So if you have issues at production, you can just bump it to JDK 11, and you will get this tool nice and for free. Another change is that string has an array of bytes instead of array of characters inside. So there used to be this famous question, you know, at technical interviews, what's the encoding used by Java to keep strings, right? Okay, and now the answer changes a little bit because strings are not kept in a byte, meaning if you were using, for example, this wasn't that much case for Poland when you have these diacritics which aren't in the ASCII scope, for example. But it turns out that a lot of world's population of strings, so to say, are written, for example, in plain English, right? Therefore, you don't need 2 bytes for every character. 1 byte is just enough. That's why if you have such a string, this string can be or can occupy half of the space on your heap. So for some applications, for example, I've seen the improvement of 16% reduction of RAM and GC cycles. And I've even heard reports saying about 40%. So it depends on the application. So even if you have like a fancy Polish name like Grzegorz, for example, still it will work for you because it has no diacritics. Okay, AppCDS, very useful thing if you want to speed up the whole startup of your Java, right? So we can pre-record like words where in which jar, and in JVM, instead of doing this every time when it starts, can simply read this. Okay, there's a link for you describing how it works. Basically, it means faster startup. There are of course better GCs. So in Java 15, ZGC and Shenandoah from Red Hat went production ready, right? Went the GA, meaning if you really care about short stop the world pauses, they're really worth trying, right? And of course, G1 is default since Java 9, right? Other big changes in my opinion, right? Java Unified Logging. Now you have one switch to log from like all Java subsystems and so on. There are no different logging parameters for this system, another subsystem, and so on. Of course, there's this Java Platform Module System / or coming from project Jigsaw, right? So now Java has modules, of course. There's JShell. Who's been using JShell? Oh, you should be using JShell, really. I'll show you. There's var, which is more than just, you know, reduce the verbosity of the code, but it can also allow you to get like a better, more sophisticated types of your variables, and we can now write scripts in Java. I don't know if that's good, but it's possible, right? And finally, well, some would say it's a bad thing. I say it's finally Java is removing stuff, right? If they find something that's really problematic in terms of maintenance, for example, in terms of cleaning stuff up or refactoring, it gets removed, right? So for example, concurrent mark sweep got removed, security manager most probably is going to be removed, Nashorn got removed, applets got removed along the way, and so on, right? So it started with Java 9, but it continues. Like, it's not uncommon now to see Java stop supporting something. So let's talk about this removed stuff. What got removed? So Java SEEE modules got decoupled. Who's using web services like SOAP, XML, something? Okay, so this thing got decoupled, okay, meaning you'll have to have separate dependencies. I'll show you that. Who's using Corba? Luckily, oh, okay. So I'm sorry for you. Yeah, so for you, sorry. So, yeah, sorry. Very nice French, I like it. JavaFX got also decoupled, right? So it's not part of, I mean, it can be a part of your JDK/JVM, but it doesn't have to be, all right? Java Web Start got removed, and many XX parameters got removed. So for Java 11, instead of almost 800, there was like not even 600 parameters, right? So a lot of stale parameters got removed, and various sun kind of save methods got removed, and then, for example, through the subsequent versions like 12, 13, and so on, other stuff got also removed. Okay, so the whole list is there. The links are there. I really suggest you go in RTFM, right? Okay, let's talk about this deprecated stuff. So actually there's new way of deprecation now. It's called enhanced deprecation, because before we've seen this deprecated and we wasn't sure, like, it's deprecated meaning you shouldn't be using this, or it's deprecated, it's going to be removed, or what should I do, right? And now we have thing called enhanced deprecation, meaning deprecated has this parameter for removal and can be set to true. And if you see something like this, right, deprecated with for removal for set to true, it means it might be removed from the next major Java version, right? So for example, you see something like this in Java 17, it means it might be gone in Java 18 or 19 or 20, meaning this is the last opportunity for you to use it safely, right? Right. So if you like if you don't compile the code because, for example, you're just pulling some jars or somebody sends you jars, I don't know, like third-party dependency, and of course you don't have the source code, so the compiler won't emit this warning for you. Then you go for the JDep scan, and it will tell you, hey, this bytecode is using deprecated code, and this code is deprecated for removal, for example, right? So maybe it should be part of your CI pipeline, basically. So you check your dependencies if something didn't get deprecated for removal, for example. Concurrent mark sweep got deprecated and eventually removed. I don't know, Java 14 or 15. NAS horn got deprecated and it also got removed. Again, 14 or 15, sorry, I can't remember all these changes. And in my opinion, so-called deep reflection also got removed, right? So let's talk briefly about modules coming from project Jigsaw. So modules are now everywhere, actually. Yeah, are they or aren't they? They are for sure in JDK. I can show you. So now modern Java versions, or modern. Let's see which Java version I have here. Java version, it's Java 11, as you can see. So Java list modules. See. It has these modules, right? So there is, meaning it has no rt.jar file, meaning you can, for example, shape your application with just a subset of these modules because, for example, you don't use SQL, right? So you don't need these modules, so the image can be smaller, for example, something like this. And our libraries and applications sometimes, I mean, I've seen libraries and applications being module friendly or even using modules, but it's not that common. If that's good, if that's bad, I can't tell. I mean, the modules or the JPMS wasn't invented for us to have modules in our applications. It was to make the JDK itself modular, right? So we can use it as a kind of byproduct, like something nice, like which is like given extra, but it's not strictly required. So there are modules in the, for example, like from Java 9 and 11, links for you again, and here are the little images. I'm not sure if we're able to see it, and you can see this little disturbance here, right? And this disturbance exactly is this Java SE, sorry, it's kind of blurry, Java SEEE module using Corba, XML, WS, meaning web service, and so on and so on. So this is the module graph from Java 9, and this is the module graph from Java 11, meaning these modules got removed. Right, they were present in Java 9 and 10 to ease migration for 1 year or something, and then from Java 11 they got removed, meaning they got decoupled. You have external jars here, or they got totally removed like Corba. All right, and why we have these modules in Java? Because of jar hell. Who knows the concept of jar hell? Who's been in jar hell? Okay, so yeah, a few people. Okay. I've been there too. Okay, so jar hell works like this. You might have classes in a single package in many jars, right? And for example, the order of the jars changes in the class path, then a different version of a class is loaded and you end up with method not found exception, right? Or for example, there was this smart administrator who decided that it should, like, okay, 3 libraries are using the same, sorry, 3 applications on our JBoss/Wildfly or Tomcat, whatever, are using the same library, so I'll extract it from their dependencies, I will add it to this container dependency, and voila, I saved RAM, I saved disk space and everything, except when this single application updated their dependencies, still they had loaded the previous versions of the classes because they occurred, you know, in the, like, before in the class path, meaning method not found exception, class not found exception, right? This is jar hell. It's like DLL hell, any other hell, like dependency hell, basically. But it also means better encapsulation, meaning now we can have public classes and public interfaces, but if they are not exposed by the module, meaning entities outside the module cannot read it, at least by default, right? And it's kind of like moving us from class path to module path. But let me say this. If you have to migrate to modules, don't think of modules as if they were a path. Think of them, as I have shown you, as a graph, right? So you have modules being like nodes in this graph, and you add dependencies as edges, right? Like these arrows. So think of modules this way, right? So again, you can repeat after me, because many people used to say, yeah, we can't go to Java 11 because this would mean that we have to introduce modules in our code and every has to be modularized. Again, BS. That is not true. You don't need to have modules and module path in your application. You can, okay, and there are certain benefits. Why not? But it's not that it's strictly required. You can still go with this Java class path, right? But remember that, as I have shown you, JDK itself is modular. It has no more this rt.jar huge file with, I don't know, 4,500 classes inside. Now this is split for smaller entities, okay? And what are the migration steps? First option I would say is install SDK Manager. What SDK Manager allows you to do is something like this, and works like super easy on Linux and on Mac. It's a bit more convoluted on Windows, but still doable. As you've seen, it's Java 11 here, right? And here I can go Java version, see it's 1.8. And here I can go Java version, okay, this was this, sorry, typo, version 11. And here, okay, so, but we can go like use, sorry, 1602, all right, and you can go Java version. So as you can see, I can switch easily to Java 16, and in one tab I can have Java 16, in another I can have Java 11, in another I can have Java 8. Very handy if you need to run your application, for example, in using Java 8 and Java 11 and compare if they function the same way, for example, or if they compile in the same way, right? So this is what, for example, you can achieve easily with SDK Manager. You should upgrade your IDE. If you have your IDE predating Java 11 due to whatever reason, the migration might not work that easily, right? Of course, you should upgrade your build tools and CI. Like if you have ancient version of Gradle or Maven, again, it might not be a good idea to bump the JDK without doing this. Upgrade containers if you have any, like Tomcat, right? For example, if you're running like ancient version of Apache Tomcat 8, it might not recognize Java 11 or something, and you will see problems and so on and so on. So first upgrade these, right? So, or at least ensure they support, for example, Java 11. And upgrade all these dependencies, because some dependencies might be outdated and they might not be aware of, for example, things that have been removed from Java 8. So for example, if you still happen to have Hibernate 4, I suggest you first upgrade Hibernate, okay? I've seen such cases. It's not so uncommon as one would think. Yeah, and you should still compile using Java 8 and try running, of course, Java 11. And if your application is a bit more convoluted, perhaps you could still try using 9 or 10 as a middle step, right? Sometimes it's useful, but not always. It really depends, right? So 11, of course, is your target, but sometimes this could be a nice baby step for you. Okay. For Java SE, EE, thing like XML, web services, SOAP, and stuff, you have to go and install external or add external dependencies to your POM or build Gradle, right? And this is important. Test and automate this stuff like crazy. Because why is worth automating? Because one day perhaps you will be migrating to Java 17, okay? So it'd be nice to have this test already covered, right? That's the benefit, not to do this just manually, but to have this automated, basically just to see if the thing works, moves, and so on. For example, there are some extra steps. You can do the other thing. If you're still, for example, running your stuff on premises, or your users are running stuff on premises, meaning they are self-hosting it, you could compile using Java C11, right, using target version as 8, and release the jar as Java 8, perhaps as a multi-version jar. There's such concept since Java 9, so we can release one jar covering more than single Java version. It's possible. It's called multi-version jar, okay? Try to switch to illegal access debug or deny. If needed, add exports, opens, and so on if you can't fix your source code, all right? So in general, two things might happen. Thing number one, you will get these compilation errors, missing class, missing method, missing something, and then you can get these runtime errors. For example, there's a problem with casting, right, like last loader and stuff. Again, something might be missing. And since we are so much used to off by one errors, a third thing might happen, which is illegal access. It is something possibly bad, but it's not strictly an error, so it's difficult. Still, I think you should get rid of this, okay? And if you have missing core bar, sorry, right, okay. If you have Java X missing something like a SOAP XML, then you have, for example, add this extra dependencies. If you have missing classes and methods, this is usually coming, like, you should stop basically then using them. And if it's coming from your dependencies, you should upgrade your dependencies. If you have some missing parameters, I don't think it's likely, but still it's possible, then you have to upgrade your scripts basically, right? Or contact your DevOps teams and so on and so on. So let's talk briefly about this illegal access. So even if you don't use modules anyway, JDK below is modular, right? So if one module is reading another module without, and things that aren't exposed, then it's called illegal access, okay? And not that I would suggest that you should give a like to this tweet, because Sergey, again, this is what happens when you use illegal reflection, okay? What a stupid spoon. Yeah, give Sergey a like. I mean, I like this description a lot, right? Exactly. So maybe you're misusing the thing if you're using reflection, basically, okay? So there are 4 levels of this warnings of illegal access. So this is the default till Java 15, and it's permit, meaning when you start your application and encounters illegal access, JDK will tell you just once. So it'll behave like your friend. It will tell you once, okay, you're doing something bad, please stop, and that's it, okay? Then it can go, I call it the wife or husband way, okay? It will do the same thing, but every time. Every time you do something bad, it will tell you, hey, illegal access, illegal access, illegal access, okay? And then it can go this mother-in-law way. It not only will do that every time, but it will also show you exactly where. This here, here, you see? It will provide you with a stack trace. And then there's final thing. I call it the father-in-law option, meaning you can misbehave, but just once. You know what I mean? And then you're dead, right? And 6 feet under, right? This is what happens with father-in-laws, exactly, right? So this is it. An important thing is, it's default in Java 16, right? So if you're considering moving beyond Java 11, just stop playing with illegal access, okay? And the worst thing, perhaps, is it got removed from Java 17. Like, so you can't even choose your friendliness level. If you have any kind of illegal access, you're just father-in-law dead, right? And you can not relax it anyhow, okay? And of course, there's this needed 5, so to patch the module graph, so to say, right? Using all of these, it's about adding these edges or these arrows to the graph of the modules, right? And please remember that all the jars from class path end up de facto as one huge all unnamed module, okay? So, meaning you can use this, for example, and use here the all unnamed, meaning, for example, add opens that you open this package from this module for deep reflection to the module, to this module, right? And then, of course, there is add exports, doing that for public stuff. You can add extra modules like something optional, for example, like optional dependencies. You can go add reads, meaning adding the edges from the other side, so the thing is reading. Basically, it's like requires in modules. And this patch module, if you really have to have the same package split among more than one jar, because the promise by modules is that the package is in one jar, meaning one module only. But you have to split it, then you go for patch module, right? And of course, then you have to go for example, add modules, add exports, and add reads. And if you have too many of these arguments, like, I don't know, 200, for example, then you can group them in these option files, right? The thing is, they are flat, they cannot be nested, but you can go for like application, so library 1, library 2, something like this, like to group them, for example, right? And distribute them, all these add opens and so on needed by GPA or DI or whatever. When migrating, please keep in mind that your mileage might vary. I don't know what's the French description for this, but your experience basically might be different. I haven't seen 2 identical migrations so far. On the other hand, I didn't do thousands, so maybe that's the reason. Okay, if you want to see a trivial migration, let's do that one. The code should be for you on GitHub. So we have a simple application, right? It's not the real one. I can't show you the real one because, you know, NDA and stuff. So what this simple application do, it has just, you know, some Java beans basically. Then it's creating XML out of these beans, right? And then we encrypting this, right, to base 64, you know, the joke, and so on. So this is what it does. Like, this business logic is basically this. Not much logic, but a lot of business, of course. Right, and it's what we also do. Yeah, we create this XML using Jigsaw, and this is the way we create base 64. And we also take this, commit this crime of calling or using deep reflection. You know, there are various ways to summon demons. Some say you should draw a pentagram on the floor. Some say you should light a black candle, right? And Java engineers type set accessible true. That's the same. That's the equivalent, okay? You summon demons by using something like this, okay? Sometimes it's inevitable, sometimes it's necessary, but usually that's the thing. And as you can see, for Java 8, we have this character array here inside this string when we get the value of this field, right? And the code should be working. Let me see if it works. Should be here. Yeah. So let's go. Yeah, what I basically do, you see I am checking out the Java 8 branch from this. It's on GitHub. You can fetch it and play with it on your own. Then I'm switching to Java 8 using SDK Manager, and then I'm going to clean and run it, okay? And it cleans and it runs, and this is what it does. You see, it prints all these beans. It creates this XML, encrypts using base 64, and you can see the 4 characters inside this character array of string, right? So pretty typical Java 8 application. Abusing everything, doing XML and deep reflection. Okay, and then you want to go for Java 9, right? So see, I just prepared these changes, right, for you, and we're using Java 9, and again clean and build, and you see it's working the same way. So what has changed? What has changed? Let's see here. See, I don't have the array of bytes, but characters by array of bytes, right? And the thing I changed here is that previous thing for base 64 got removed. So I had to switch to Java util base 64, get encoder, get decoder and stuff, right? Because that previous API got removed. I remind you, since Java 9, things started to vanish from Java API. That's expected, right? But beside that, not much changed, but you see this thing. So let's examine our build Gradle, and you see I've said Java 1.9, right? And of course this should be updated to, for example, Maven Central as well, because no more JCenter and stuff, as you can see. So even if you don't touch the code and it still works, it just gets older and older, right? And as you can see, I had to add these compiler modules and these runtime options. So as you can see, I've added, for example, this add opens, meaning open the Java lang package, I mean Java lang string, from the Java base module to everything that's in the class path. So I can do this. If I don't have this parameter, right, let's remove it altogether. Let's see what happens. Right, let's go for a Gradle run, just run. We don't have to recompile. Then it says, you see, you have this illegal reflective access. Okay, so one thing some people you can do is go for this illegal access permit, for example. No, don't do this. Just stop doing this. The best thing you can do is basically stop doing this set accessible true. So here we should go for actually the input get bytes. For example, see, I'm getting rid of this. I'm getting rid of this, yeah, this is what I do. Yeah. So if you see something like this, you get rid of set accessible true. This is what you do, and the warning vanishes, and the thing will continue to work in Java 16 and 17 as well. Okay, that's important if you want to go, for example, for Java 17. But let's say this is foreign code, like foreign dependency, and you really can't do this because these morons don't want to do that and insist of summoning demons. Then what you have to do is then you switch illegal access to debug. So then it will, print you when you go for, let's remove this and let's go, yeah, debug, exactly. When we go for debug, then it will show you exactly, you see the stack trace. So you can see what's going on, where the illegal reflection happens, right? And then having this, you can go and use these add opens, and you say that, okay, I know this is bad, but I'm kind of like giving you a blessing, right? So you can proceed, okay? I know it's bad, but let's go, okay? And then you see it works without this warning, and you get the contents of this byte array. The other thing is here, this add modules, and I mind you, this works with Java 8 and Java 9 and Java 10, right? If we don't add this module and try to, oops, too much, and try to run this thing again, you see it fails because it says class not found exception Java XML bind something. Meaning for Java 9 and 10, you can still like, it's there, but it's not enabled by default. So we enabled it manually, okay? It gets enabled, and as you can see, the thing is running. And then what you can finally do is try to go for Java 11, right? And still the thing is working. So let's see what has changed. You see, I can no longer go add modules and go for Java XML bind or Java SEEE. What I have to do, I need to add this implementation or compile the old style way or just any dependency. So I say, but by the way, as you can see, these are outdated, right? And I still keep this add opens all unnamed. So this software should also work. Let's give it a try. Oh no, it's because it will use this version, but it will work in Java 16 and 17 as well without any further changes if you have these add opens, and you need to have them if you can't change the source code, right? So that's the thing. So this was this trivial migration, and if you're working, for example, with Spring, who's working with Spring? Okay, many people. Then it's the, you know, this pet clinic. Okay, so one guy migrated to pet clinic, even into modules. I mean, that's not needed, but it's still optional. You can do that. There's another blog entry for you. Other things which might be interesting for you is, for example, this. Do you see what this is? Do you know what this is? It's a thing called JShell script, basically. So I believe we should be able to call it, right? And we can go like this, because JShell is interactive, of course. As you can see, I can go for, I don't know, 2 + 2, and it's then int 4, for example. I can go like int a equals time +2. So it's Java, basically, only one byte line. So we don't have to go, for example, like create this yet another main method or so on. You can go for JShell. And what you can also do is you can write it as a script and go JShell, as you can see, make var. Of course, not war. We're not about making any wars, but just make var. As you can see, except this exit at the end, right? Everything else is just Java code. Okay, it's using this var or even abusing it because it's Java 10, right? But it's working like, as you can see, it has the streams, system out print line, and so on and so on. Okay. One thing you can also do with Java is, let me find this. Okay, this thing. What does it look like to your eyes? Don't be shy, shout out. It looks like Java, right? One thing is different. What's different? Where's the difference? Okay, the difference is here. It's so-called shebang. You know, the bin, shell, bin, bash, okay? So now we're telling, we're using it to say that Java is the interpreter of this file. And if I have this file, as you can see, it's runnable, it has this X, then see what I can do. Sorry. JavaScript, boom. I can write scripts in Java, and even has this pesky emojis, okay? Right, also the JFR, so if you have, for example, problem at production, you can record this JFR file. Let me go here for the build Gradle. As you can see, I can now use this xlog, meaning Java Unified Logging. I can say log everything GC related as a debug to file. Of course, don't log to TMP. It's just for demo only. And you have this GC log file. Okay, so it's like this GC log, and you can start analyzing this file. Okay, it's quite big file. I would say it has almost 20,000 lines. for a simple run. But you can, you can analyze every GC pause and so on and so on and so on, why it took place, and every possible detail. See, it's just that nice file. But let's say you don't have a parser in your eyes and in your brain. So what you can do, you can then go for this build Gradle, and you can start using this flight recorder, meaning you are writing stuff, for example, to recording JFR. Of course, don't use TMP. I do that for demo only, right? And then you open this file in a thing called Java Mission Control, right? And then it analyzes stuff for you, and you can see, for example, that there were problems with threads allocating, or even there's a problem that one of the arguments of your Java application was named password, as we perhaps, as you can see here, right? Don't provide passwords as parameters, because then anybody can PS and see them, basically, right? So that's why you don't do it this way. And as you can see, there are problems, and the problem is, for example, that this thread, this producer thread, is allocating way too much, right? So meaning you can then, knowing this, you can go for or find this producer. Do I have this producer here? Right. Yeah, I see producer, and we can start analyzing why this producer is crashing our application or causing out of memory error. And it does it because it's offering something every 50 milliseconds, whereas the consumer can consume every 100 milliseconds, right? So we get out of memory exception, see? And you can see it here. For example, this is a problem with garbage collection, so we can see every garbage collection and so on and so on. It took so much time at this period of time. You can see as the memory grows and so on. You see? Profiler for your production, and it works like this. You can attach to a running process, record, for example, 1 minute, download this file and analyze it offline, right? Just like with the black box from Airplane, right? And now it's for free, meaning you don't have to pay it, or you don't have to be criminal using this feature without paying for it, okay? So that was it, mesdames et messieurs. And my request for you, not just this talk, but for every talk you ever attend, every speaker, every conference, every meetup, JAG meeting, and so on, please always provide your feedback. Okay, say how it was, what was good, what wasn't bad. So what was good, what was bad, and so on and so on. So we, the speakers, can improve. The organizers can improve this stuff for you. It's in your interest. Likely this time I can accept even paper forms. So if you have paper forms, I will accept them. Today. Thank you very much. Merci beaucoup for you being here, for attending this talk. I wish you happy migration, finally, at this time. And these are the slides for you. Thank you very much. Dziękuję bardzo.